Welcome to this next lecture, and we were discussing about 120 degree phase spread winding. So, we took a rather simple example with two number of poles. Well, if the number of poles are 4, slots are different, then how to handle this? Suppose here is the example. Suppose total number of slot is 24 as is shown here, and number of poles is 4. Okay. And I want to do a winding whose phase spread is 120 degree, all electrical. Therefore, you can see the number of slots per pole is 6, and that is equivalent to 180 degree. From there you get the value of beta to be 30 degree, that is fine. But to carry out the 120 degree phase spread winding, you should allot under a pair of pole 1/3 of that 360 degree, that is 120 degree to R phase, 120 degree to Y, and 120 degree, rest 120 degree to B phase. Therefore, here how many slots I should spread for R phase coil? It should be number of slots over a pair of poles is 12, is not 2 into 6, 1 pole. So, out of this 12, R phase I will allot 12 by 3, 4 slots, Y phase I will allot 4 slots, and B phase I will allot 4 slots. That is the idea. Okay. And these 12 slots will make 2 poles, is not 12 slots will make 2 poles. So, that is the idea. Now, how to do the winding? Forget about this filling up this void spaces in the slots, that we can always do, provided I have a correct winding table. Then the rest of the work of filling up the windings here is easier task, provided you have made a winding table which is correct. So, in this case, what I will do is this winding table, while making, I will do it in this fashion, this data I keep. So, for R phase, I start from slot number 1, first coil. So, and how many coils are there? Total coils are 24, do not forget that, and each phase must have 8 coils, is not, these are known. So, 1, 2 and coil span is 6, therefore, it will be 1 7 dashed, 2 8 dashed, 3 9 dashed. I do not stop here, I will give 4 in succession and 4 10 dashed. And when I have done this, that is, I have made a distribution of the group 1 coils belonging to R phase. And when we have moved this much, I have moved by 2 poles, and only 4 coils have been covered. Where will be the other 4 coils of R phase? Because each phase has 8 coils. Where from should I start? Should it be 1 plus 6 7? No, 1 pole pair is over. So, this is one north and south. It is a 4 pole machine, and next pole pair will be here, north and south, that is all. Therefore, the start of this is group 1, phase group 1 of R phase. This point is important. So, it should start from 1 plus 12, 13, once again from this thing, 13 plus 6, 19 dashed, 14, 20 dashed, 15, 21 dashed, and 16, 22 dashed, and then all 8 coils are over for R phase. I am repeating. See, that number 4 I have got over, this is this length covers a pole pair, and this length cover another pole pair. So, in this pole pair, first 4 coils, this number 4 I have got from this. So, 1 7 dash, 2 8 dash, 3 9 dash, 4 10 dash, and then next pole pair starts, once again starts with naught. Therefore, 1 plus 6 plus 6, that is 13 19 dashed, 14 20 dashed, like that. Similarly, Y phase beginning will be 120 degree apart, that has not changed, that has to be complied with always. So, 1 plus 4, that is 5, and then 11 dashed, and once you get this, then 4 coils under this pair of poles. So, 5, 6, 12 dashed, 7, 13 dashed, and 8, 14 dashed. Okay. And then this thing, what I am telling, after 2 poles, that is you add 12 to 5 to get 17, and then plus 6 the coil span, 17 6, 23 dashed, 18, 24 dashed, 19, 25 dashed. So, 1 dashed, 20, 2 dashed, 1, 2, 3, 4, 5, 6, 7, 8, all 8 coils are over. And then B phase, five plus 4 9, 120 degree apart, 9 16, 6 you add, 15 dashed, 10, 16 dashed, 11, 17 dashed, and 12, 18 dashed. Then next group of B phase will start from by adding 12 to 9, 6, 6 after 2 pole apart. Therefore, 9 plus 12, 21, 21, and then 6, 27 dashed, 27 dashed means 3 dashed, then 22, 4 dashed, 23, 5 dashed, and 24, 6 dashed. And you will see all the coil sides will be in place if you want to carry on this winding. You can now go to that slots arrangement and find it out. But here one thing I want to, I have not kept enough space, but the thing is, if I draw the coils like this is 1 7 dashed, this one I am reproducing in terms of coil, which is much easier to apprehend. 3 9 dashed for R phase I am showing, and 4 10 dashed, and potential of 1 with respect to 7 dashed plus minus, this will be plus minus, and this will be plus minus, this will be plus minus, and you connect this in series to get the first group of R phase. Second group of R phase will be 13, 19 dashed, quickly let me do 14, 20 dashed, 15, 21 dashed and 16, 22 dashed. Here what should be the polarity? Once again same, because this 13 and 1 are similarly placed at a given instant of time. So, this is plus minus, plus minus, plus minus, plus minus, and you connect them in series, get the group terminals here. Therefore, in this case you have to ultimately connect these two groups in series. It will be just like minus to be connected to plus. So, you can proceed to connect in that way. So, this is plus minus, plus minus, plus minus, plus minus. So, this is plus. So, minus, then go there, plus, and these two will be the terminals of R 1 and R 2, and similarly for y 1 and y 2 you can do. Therefore, I have taken a slightly involved 120 degree phase spread winding, because two polar is too simple a thing. So that you do not be under the impression it cannot be done for higher poles or higher number of slots and so on. So, we find there will be two groups of R phase. Y phase similarly it can be drawn, which I am not doing, I will leave it to you. Therefore, in case the conclusion is, in case of 120 degree phase spread winding, number of group of coils will be equal to number of pair of poles p by 2. See, in this case number of poles were 4. So, 4 by 2 2 groups, one group, two group. This is one thing, and in case of this we have seen earlier 60 degree phase spread winding, number of group of coils, number of group of coils of a particular phase, of a phase is equal to number of poles straight. 4 pole 60 degree phase spread winding, if you look back you will find for R phase there are 4 groups, one under north, one under south, one under north, one under south. But in this case the very distribution takes place based on under a pair of poles. So, over a pair of pole you have 120 degree allotted to R phase in immediate succession, next 120 degree. Therefore, as many pair of poles will be there, so many groups will be there. Understood? Therefore, if it is a 6 pole machine, you will soon discover there will be 3 groups. Only interesting thing is the polarity of the voltages. Here, okay, it goes fine, because 1 starts under north pole, 13 also starts under north pole. Therefore, there they will be of like polarities, and therefore, they can be straight away connected in series. However, in case of 60-degree phase spread winding, you should be careful while connecting several groups in series. One point I would like to tell, be it 120-degree phase spread winding, generally group terminals are available, you connect them in series. Okay. Sometimes the group connections in the winding itself will be connected inside, and you will be machine will give out these two terminals, phase terminals, ultimate phase terminals. But in any case, what I want to tell you is that when the group terminals are available, it is sometimes available. The reason I will tell you later. The connection among the groups should be carefully done. And I will ask you a question later. Suppose somebody makes a mistake in that group connection, what could be the effect of that? Those are very interesting things. Okay. After machine has been wound, groups are available, okay, they have to be connected in series. Also, it is to be noted, these groups may be also connected in parallel, it does not matter. These groups, say group 1 R phase, these two terminals and these two terminals, they are identical, all the voltages are. They could be connected in parallel and brought out. For this is done for low voltage, high current machines. The outer current. So, if the groups group 1 and group 2 may be connected in parallel, why not? And say this is your R 1, this is your R 2. Parallel connection requires that voltages at all times must be same and connect the like terminals, but do not connect plus with minus and minus with plus, then there will be internal short circuit of those two group voltages. Similarly, a 4-pole machine, I mean 60-degree phase spread coil, for example, here there are 4 groups 1, 2, 3, 4, they can be connected in series, and also all these 4s can be connected in parallels, or 2 2 you take, connect them in series and then the combination in parallel. But in that case you have to be only careful about the polarities. So, generally for high voltage machines, the coils will be connected in series, so that it gives you appropriate voltage. Of course, no one stops you if you connect the coils in parallel and then specify the voltage. So, this I will not tell. See, winding is a very big thing. There are other types of winding, fractional pitch winding, this, that. We will not go, but I have considered the winding to be one of the most important thing one must understand before he learns about how a rotating magnetic field will be produced by stationary polyphase balanced winding. That is the reason I went rather deeply into this, and here about the windings I will not make further comments. Whenever I say it is a balanced 3-phase winding, I know what it is, what does it mean, and when they carry current will be discussed right now. I mean, there is now no stopping. After I have gone through this few lectures about the windings, I think you will be placed in a better position to understand what exactly is going on when a balanced 3-phase distributed winding will be excited by balanced 3-phase current. Achha. So, So, the introduction to that will be in this way. Let us now try to understand that you have, suppose the if some current is passed in a balanced 3 phase winding, then there are 3 phases. R phase carries current, it produces its own magnetic field, then Y phase too will carry current, produce magnetic field, also B phase produces magnetic field of its own depending upon its current. If the winding is balanced, externally I will show it like this. Suppose R 1 R 2 is the R phase 2 terminals. These 2 terminals I am talking about after group connection inside the machine, which are available to me. Similarly, suppose Y 1 Y 2 is Y phase and B 1 B 2. This is how I will now represent the coil, and suppose they are connected in star, R 2 Y 2 B 2 are short circuited. Okay. And what I am telling is this, these 3 windings, and this winding is suppose, I mean carry current like this. Now, if you have a 3 phase supply, please do not miss any point when I am telling this, this is very important. If you have a balanced 3 phase supply, it is a balanced 3 phase, it could be stator, rotor winding. Let us assume stator houses this balanced 3 phase winding, and I will connect it to a 3 phase supply, is not? I will connect it, and suppose the supply phase sequence is also like this: R, this is Y and this is B. R Y B is the supply terminals, and since these windings are balanced, so they will take balanced 3 phase current. This is I R, I B and I Y. Balanced 3 phase sinusoidal current they will take, because it is a balanced load connected across a 3 phase supply. Therefore, each coil is carrying time varying current. Okay. Now, when they carry steady state current, we know what is the consequence. For example, if you pass a DC current to any of the coils, say R 1 R 2 individually, suppose I have passed some DC current of constant value I, what it will do? It will make a space distribution of B, okay? Space distribution of B will be there, and if you consider only the fundamental component, it will have a peak value of this B. So, this is theta space angle, I am passing a constant current, only energize the R phase, drawing a constant DC current, and it will generate a flux density distribution across the air gap of the machine, and this is B R. This is 0, this is all electrical, okay? This is pi, this is 2 pi. And there will be some maximum value associated with this current. What do you think if I say that I will energize the same coil with DC current, but I DC by 2, half, I have made the current half. What will be the flux density distribution? So, this is with I DC. If you make the current half and if you assume linearity, the maximum value of the current depends upon number of turns and the magnitude of the current here. So, it will then become half. The same pattern, but only thing its peak value, if it was B max earlier, it will become B max by 2, make it 1/3, it will become 1/3 and so on. Therefore, I know the effect on B distribution as you change the magnitude of this current. Therefore, if I now say that this coil R1 R2 is carrying a time varying current I t, which is of the form I max sin omega t, then the MMF distribution, this is space, mind you, space. Now, the current magnitude is changing on its own. I do not have to change, connect another DC source, pass I DC by 2. It is on its own, it is changing. When it will be 0, this B distribution, there will be no B distribution, this will be this axis only, that curve. When current becomes 1 ampere, it will have some B distribution like this. Current increases, it will be like this. Current becomes I max plus I max. So, this is due to for I max, this B distribution. And I also notice this current will become negative sometimes. Then the polarity of the B will be also negative, depending upon the magnitude of the current. Getting? So, this will be the kind of wave or MMF distribution, flux density distribution along the air gap of the machine. We will continue with this. Thank you.